Okay, so today we're gonna review slash kind of learn about this next chapter. We got covered a little bit yesterday, not a lot. So today I'm gonna go through it all and maybe re-explain some things, and hopefully we can get something out of it. So sit back and hold on to your seat and enjoy the ride, and maybe pick up a couple things or two here. So. First it says here, tell how the graph of each equation is related to the graph y equals x squared. And you all know that x squared makes a parabola, which is shown in red up here, okay? Now if you remember from earlier in the week or last week, I gave you along two sentences, okay? And those sentences' main words were, if it's on the outside, and if you look on my board here on the left here, if it's on the outside, we change the y values and we do the same operation, okay? And the other half of this would be if it's on the inside. So on the inside, we are going to change the x values and we're going to do the opposite operation. Okay, so using that information up here, if you look at number 1, we got to ask myself, where is the 2 located, on the inside or the outside? Yes, it's on the inside. Okay, so if it's on the inside, that means we're going to change my x values. Which direction does the x-axis run? Yep, left and right. Okay, so the x goes left and right. So this is going to move left or right, and we're going to do the opposite thing of what's happening. So since there's a plus 2, we are then going to do the opposite of plus 2, which is, yes, minus 2. Okay? Minus 2 on the what values? The x values. So which direction would minus 2 be on the x-axis? And on this one, that means we are going to go left 2 units, because this should be a minus 2 because it's the opposite. So if you look here, that would be what my equation looks like for number 1. Alright, let's try number 2 now. Okay, so if I have number 2, I need to do what first? I need to get the letter y by itself. So what I would do first is move that 2 over. Okay, so I'd add that 2 to the other side. And now I got to ask myself, again, using the 2 sentences that I have up here. Okay, is that 2 on the inside or the outside? And it is on the outside because there's actually no parentheses there. Parentheses are pretty much anything inside the parentheses is on the inside. Since there's no parentheses, automatically outside. Okay, so outside, what values change? The y values, which direction does the y-axis run? Up and down, right? So let's put my parabola back to normal here. So if this 2 is on the outside, we're going to change my y values and we do exactly what it says. So since it says plus 2, that means we're going to do what here? We're going to go up, not yup, up 2 units. Plus 2 on the outside. Same operation. Alright, I want you guys on your paper to try number 3 now. So same thing, think about the inside and the outside. And try number 3 for me on your paper. So I'm going to add that 1 over. Alright, and again, you always start at the origin. So that's my original parabola. What's the plus 1 on the outside going to do? Outside changes my y values, which run up and down. The y-axis is up and down. The x-axis is left and right. So on this one, outside means I'm going to go up 1. And what's on the inside? A plus 3, which means actually on the inside it's the x's and we do the opposite. So what's the opposite of plus 3? Minus 3, which means we're going to go up 1 and left 3. Alright, try number 4. So let's graph that first here. So that means I'm going to go up 1 and I'm going to go left 1, 2, 3. So that's where number 3 would land. Alright, and let's do, I'll try the last one. So I'm gonna move these around, try the last one. Alright, so I'm going to move that 2 to the other side. That means it's going to go which direction on the outside? Outside are my y values, same operation. So this right here would mean we're going to go down 2. And where am I going to go on the inside here since it's the opposite and it's the x-axis? So it'd be a plus 3 on the x-axis, which means it's going to go to the right, because right goes in the positive. So, right 3, 1, 2, 3, and up, or sorry, down 1, 2. So we're going to slide down 2 units, and that would be where my equation lands. Okay, it's just shifting translations. We did this last year in Algebra 2 a little bit. Not a ton, but we got it started last year. So today what we're going to be talking about is called periodic functions. Okay, if you think of a periodic cycle, or a period, it goes for a full cycle. Okay, ocean waves would be periodic functions. Okay, or the amount of daylight. Every 24 hours it will repeat. 24 hours, it's a new day. 24 hours, it's a new day. If you guys look at these waves, there are 3 periodic cycles up here. Okay, each one is exactly the same shape, and it has a starting point and an ending point, and they all start and end. Here's another cycle, the same distance. So a full period would be from the starting point until the ending point, and that's the length of a full period. Alright? So a function, f, is periodic if there's a positive number, yada yada yada. The smallest period of a periodic function is called the fundamental period. This is a question that the book will ask us. What's the fundamental period of the function? So however long this distance is where it starts and stops, that is the fundamental period. Alright, so it says graph. The graph of a periodic function is shown below. Find the fundamental period of f. So I got to look up here and see where does my shape repeat itself. Okay, so when I'm looking up here, there's 2 shapes I see. What's some that you guys see? Yep, so I see maybe, do you see how we got a V from peak to peak? Okay, could I slide that V over and it matches up again? Yep, there's another cycle. Could I slide it over again? Yep. So how long would that cycle be if I'm trying to figure out the distance there? So from peak to peak. So how long is it from here to here? Well, if I go down here, it would be from -3. So it'd be 1, 2, 3, 4. 4 units from there to there. Let's say instead of from peak to peak, could I also just go from valley to valley, so lowest point to lowest point? And then let's go back up to the x-axis. So this starts at -1, so it goes from -1, so 1, 2, 3, 4. So it's 4 units again from here to here. So the top would be peak to peak, 4, and bottom is 4. Alright, what if I actually did a different starting point? As in, so this should be the distance, put that up here. What if I started at the origin, and I did a little mountain, little valley? Could I then repeat that and go little mountain, little valley? And I can. My graph was alright. And again, how far is that unit from there to there? And my marks are a hair off. So I guess we can't count that because I made those up and they're not the same distance. So it'd be 1, 2, 3, 4. So again, it's 4 units. So what is the fundamental period of F for part A? The answer to that is 4. Alright, part B. What is F of 99? Okay, so if this is the same pattern, and every time I go 4 units it lands on the same number, let's think about that and let's look here. So if I started right here, and I went 4 units. 4 units later, what's the height still at? So what's the starting height at? 2. 4 units later, what's my height still at? Still 2. Alright, let's go 4 more. 1, 2, 3, 4. What's the height still at? 2, yep. Let's go 4 more. What's the height still at? 2. Well, let's go 4 more. And 4 more. I'm off the board right now, you can't see me, but I'm right by the fridge. And now I'm over by the American flag. And now I'm over by the cell phone thing. Okay, every 4 it will keep repeating forever. Okay, and every 4 it will be the same height. So I gotta figure out how can I get out to 99, which would be past the cell phone case through the lockers. Okay, how would I get to 99? Well, if I'm trying to get to 99, I would probably need to go in groups of 4. So one way of doing this is figuring out what number goes into, how many 4s can go into 99. So I would actually go in my calculator and go 99 divided by 4, and you get 24.75. I would then not worry about the 0.75 and take 24 times 4. And what does that give me? 96. So every 4, it will be out there to 96. How many left over would I have? Because I'm still trying to get to 99. How many would I have left over? Yes, 3. So then F of 99 is also the same as F of 3, because there's 3 left over after you did all your groups of 4. Okay? And then from that step, once I know what that is, I then need to actually solve what F of 3 is. Normally it's F of what? Normally it's F of x, so we know x is equal to what number here? 3. So if I go to my x-axis and I figure out where my graph is, that would be down here. What is my y value now going to be at that spot? And correct. So this answer is -2. So if I started here and I went every 4 and I got all the way out there, I would land way down here at the bottom again when it hit F of 99. So -2 would be the height there. It's a periodic function. Go on forever. Alright, next one. If a periodic function has a maximum value and a minimum value, then the amplitude is this formula. Okay? So what does this formula stand for? Well, this stands for my maximum height, and this stands for my minimum height. Now when you guys think about amplitude, how many of you have ever thought about like amps on a guitar or in music? Okay, amplitude, a heartbeat monitor could have amplitude because it's like beep, brrr, beep, and just kind of keep going up and down. Okay, amplitude is all over. And this is how you find it. It's pretty much the average of the highest and the lowest points. So let's use this formula and write it down here. We will use this. If it's in your book, if you want to open your book to this section, section 4-4, you'll find it in there. I'm going to move on. Find the amplitude of the function. So I'm given a function here, I want to find the amplitude. Well, the formula is the max minus the min divided by 2. So max minus min all over 2. So what's my highest point here? 2? What's my lowest point here? -2. What's the formula have in it? A minus sign, which then what does that turn into on top? Correct, a plus. So what's 2 plus 2? And 4 over 2 is 2. So my amplitude on this problem would be 2. What does that mean? Well, from the middle it goes up how many? Up 2, and it goes down 2. But the amplitude is 2. Okay? Questions on that? Amplitude, I think that's pretty self-explanatory. Graph of this function is shown below. This is a little different. First off, is this periodic? It says it is. Could this be the same starting point and ending point? So if you look up here, could you grab a shape and just move it and it'd be the same exact shape? Some of you might go from here. Down there, little mountain, big spike. Does that repeat now? little mountain, big spike. Little mountain, big spike. Well, how big is that fundamental period? Count it out for me right now. And again, this is 4. 1, 2, 3, 4. Alright, let's not do little mountain, big spike. Let's go a little crazier. Let's go from valley to valley, because I told you that works if you have the same pattern. So, kind of a big spike and kind of angle down. Could this transfer over here? Oh, look at there. Why'd you look at that? Alright, so, how far is it from peak to peak, or from valley to valley on this one, I guess? How far is it from here to here? Count it out. 1, 2, 3, 4. So, what is the fundamental period? 4. Alright, I also need to find the amplitude on this. Okay, and you could have went from peak to peak, so I go from peak to peak, how many is that? 1, 2, 3, 4. Peak to peak, which actually now would look like this. Okay, that's also 4. Alright, so now I want to find the amplitude. Okay, so if I want to find the amplitude, so fundamental period is 4. Amplitude is what formula? Solve that for me quick, just jot it down. Alright, max minus min divided by 2, what's the maximum height? 2, what's the minimum height? 1, subtract them, divide by 2, what is my amplitude? Oh man, can I not make a mistake here? What's the formula? It's max minus the minimum divided by 2. So that now turns into a plus, which means it's 3/2. So if you found the middle area, somewhere out here, it would go up 3/2 and it would go down 3/2, and that is the amplitude. Alright, so here's the cool thing too. If you all look over here on the right side, we got 2f of x, and we got 1f of x. And if you look at that formula, or the on the board up here, we got the outside, and we got the inside. Change my y's, x's, same, opposite. Alright, so using those sentences that I gave you, they're on the board there behind my desk. Where is this 2 located? Inside the parentheses or outside the parentheses? Yes, outside. So if it's on the outside, I'm going to change what values? The y's, which ways do those go? Up or down? And we're doing the same operation. What's the operation that's happening between the 2 and the f of x right here? And that would be multiplication. So I'm going to multiply every y value by what number? 2. So I'm going to multiply every y value by 2. So here's how you're going to do this, and you're going to do this on the assignment today. Okay, you're going to take the height, because it's the y values that change. How tall is this right now? 2, yes. So if I take 2 times 2, what's my new height going to move to? 4, which you see how that bounced up to there, stretched out. Let's say I take this point. What's the height? 0. So what's 0 times 2? 0, correct. What's the height here at? -2. So I take -2 times 2, it gives me a, fall off the screen there, -4. So you now see how essentially when there's a 2 on the outside, the height doubled. And you'll be having to do something like that today, where you'll have to actually graph it, draw the parent graph, and then show me what the new graph looks like. Now, this might be a little hard for some of you to see, so maybe I'll change the background color for you. Solid fill. Can we see that? So, that's alright. So on this problem here, again, the red is my original, so if the red's my original, first off, where is this located? In or out? If you look on my board over there, it's on the outside, so what values change? The y's, that's up and down, and we're doing the same operation. So if the height here, or the y value here, is at 2 on the y-axis, and now I'm taking it, there's a half, and it's being what? Multiplied. So since it's the same, I'm going to also multiply. So I'm going to take every y value and multiply by 1/2. So what's half of this 2 over here? 1. So then you see how that would then shrink down here? What's half of 0? Still 0, it doesn't move. Half of 0 doesn't move. What's half of this -2? And the answer there would be a -1. Now it moved down to there. And you see how it's half as tall? Or it's shrunk vertically. Alright, let's look at the next one. So now, so f of x again is that normal red one that we started with. Now, where is my 2 located here? On the inside or the outside? Use those sentences on the board over there. Okay, it is on the inside. So on the inside I'm going to change my what values? The x's. Which directions do the x's go? Yeah, left and right. Nice. Okay, and I'm going to do the what here? The opposite. So whatever it tells me to do, I'm doing the opposite operation. So opposite means opposite of what's going on inside here. What's happening between the 2 and the x? Yep, they're being multiplied. So if they're being multiplied, I'm doing the opposite of that, which would be what? Division, correct. So I'm going to divide every x value by what number? 2. So let's just think about this. So start at the red one. I'll use blue dots so it makes sense. Okay, so these are all points on the graph that we're going to move. Okay, so if I just pick random points, they're all on the graph. And we're touching only the what values here? The x's, because the x's are on the inside. Okay, so what's the x coordinate for this origin point here? X is 0, yep. So if I divide, because I'm doing the opposite of multiplying down here. Okay, if I divide by 2, what's 0 divided by 2 give me? 0, yep. What's the x value here at? What's the x value at? 1, yep. So if I have 1 and divide by 2, what's 1 divided by 2? Half. What's the x value here at? 2. What's 2 divided by 2? 1. What's the x value here at? 3. So what's 3 divided by 2? 1.5. What's the x value here at? 4. What's 4 divided by 2? 2. You guys notice where we're at here? Here is a full cycle. We'll keep going and I'll show you the next part. So now what's 5 divided by 2? 2.5. What's 6 divided by 2? 3. 7 divided by 2? 3.5. 8 divided by 2? 4. How many cycles are in between here? You guys see how there's actually 2 cycles? Where there used to be just 1 cycle. So the one red cycle was from 1 to 4. Now, you see how when there's a 2 in here, there's twice as many cycles. So there's twice as many cycles on this one, which you see how it's twice as many blues up and downs. Alright, so that essentially, since it's on the x-axis, it is shrinking horizontally from left to right. You see how when you multiply or divide, the shape changes, but when I add or subtract, your shape will not change, it just moves up and down and left and right. So these are the harder ones versus the pluses and minuses. Alright, now what's happening on this equation? Where is it located? Correct, on the inside. What values change? Man, you guys are awesome. Yep, and how do you do the same or the, oh, you already got it, yep, the opposite. Okay, so if I'm going to do the opposite, what's first happening there? Isn't there multiplication going on here? So multiplying by a half, what's the opposite of multiplying by a half? Dividing by a half. Well, I can't divide by a half because it's a fraction, so instead we multiply by its reciprocal, correct. What's the reciprocal of half? 2. So I'm going to multiply every what value by 2. Every x value is multiplied by 2. So now x's go left and right, so now it's doubling on the x-axis, which means it's blowing out left and right. Okay, so if I go back to my original up top here, and do my points again, I'm going to get rid of that guy here. Okay, so if I land my points back on my graph, here's a point, here's a point, here, here. Alright, good. Alright, so what's the x value here at? 0. If you double that, you're still at 0. What's the x value here at? 1, what's 1 doubled? 2, what's 2 doubled? 4, what's 3 doubled? 6, what's 4 doubled? 8, what is 5 doubled? 10, okay, and then that would be at 12, and this would be way out here at 14, and, oops, so we're at it, yep, this should have been 6. This one here is way out there. Anywho, get rid of those, because we actually need those. Okay, and I need one more here, where we at here, so 0 was there, 1 went to 2, 2 went to 4, 3 went to 6, and, oop, missed one there. So if we're at 4, 4 doubled goes to 5, 6, 7, 8. And if we look here, do you see how it's twice as big? Or if you look at where we started on this cycle, where the red cycle was full, now the blue cycle only has half of a cycle, which that's the reason why down here, same picture here in purple I just drew. Okay, that's why you see how now it's blown up twice as wide, but it's half of a cycle in that normal period of 4. Now my period on this purple one would be what number? So, mountain, valley, how far is it from there to there? That's a fundamental period. And 8 would be the answer. Okay? Alright. Shifting, we talked about that on the first slide. I want you on your paper and jot down what's the new formula for this red equation. So the black one is the one given. How was it shifted? Write it down. Now, all these probably have to have parentheses, and what do you guys know about a parabola that's going to have a what on it? A squared and probably an x, right? So where is it shifting from the black to the red? We know it's moving to the right 2, that's on what axis? X's, which means it's going to be on the inside, and we're doing the opposite. So what's the opposite of a +2? See how it goes on the inside? Alright, what's happening here? It's going which direction? Up. So if it's moving up, that's on which axis? That's on the y-axis. Well, we know about the y-axis. It's the same. So it's still up. 1 plus 1. And where is that located? On the outside. So then there would be my new equation. Alright. Next one, sketch the graph of the following equations. What is the absolute value function going to look like? What letter? A V, correct. So, remember the V is the same up 1 over 1 slope. Okay, so there's my V, that's my original. Alright. Let's use the same rules on the outside and the inside and shift this thing. So you can just tell me where it's going to move to. This -2 will now be a +2. So where's the +2 located? Inside or outside? Outside. So outside for which values? The y's, and we're going to do the same. So y-axis runs up and down. So what would this mean? We're going to go what? Up, 2. And then what are we going to do on the inside here? The opposite, and it's the x's, so that runs left and right. If it's the opposite of -3, it would be a +3. So I'm going to go up 2, and then plus to the right, 1, 2, 3, and there would be my graph from the original. Alright, let's go back and do the third one. So the third one has a +5. Where would that move to if I start from the original, which is this guy right here? 5 is on the inside. We're going to change my x's. That would be left and right. Do you see how these pluses and minuses are the shifting? My parabola, or my absolute value, doesn't change shape. All it does is shifts. So this would go which direction on the inside if it's a +5 opposite? So it would be back what? 1, 2, 3, 4, 5. Alright. Graph of periodic function is shown below. Actually, I've already given you this graph. Now this is something you're going to have to do on the assignment that I'm going to give you here. So sketch the graphs of y equals f of x plus 2 and f of x plus 2, where this 2 is on the inside. Actually, I think you guys should probably be able to do that, right? On the inside, which way we're moving? Left, right, because it's the opposite. So we're going to go left 2. So again, all you have to do up here is pick all these points and just move everything which direction then. Left 2. So left 1, 2.